Hello, everyone. So today, as promised, I'm going to be doing my first experiment. This experiment is basically just going to be proving that gravity is a myth. We're going to be exploring why um, they try and push this gravity myth so much, and I'm going to be really revealing the actual truth, the actual truth. What is this mysterious force keeping us on Earth? So I've got three objects in front of me. And I just want to point out, Globers hate stuff like this. They hate these really simple experiments because they try and confuse us with these big fancy experiments and these big long words. And all you really need is three objects that weigh differently in your living room, and you just drop them, and you can just see for your own eyes what's going to happen. So the reason I'm doing this is that you hear a lot of science facts thrown around by the science community. Things like all objects fall at the same rate in a vacuum regardless of mass. Well, yeah, they're going to say that, aren't they? We're on Earth, not in a vacuum. Space is apparently a vacuum. I mean, it's. I'm not exactly living in a Hoover bag or anything. I'm on Earth. They say Earth bulges slightly at the equator due to rotation. I mean, if that was true, the Earth would just rip apart, wouldn't it? You think if you got an apple and then you like squeeze it down, it's go bang. Um, Black holes, they talk about black holes and how black holes couldn't exist without gravity. Um, yeah, I mean they're fake. It's just an extra step, on top of this narrative of trying to Alexa stop, trying to prove that gravity is real. So I need to go to the shop. So let's quickly get this done. So firstly, I have a fork, heavy object, a little rubber thing, medium weight, and a sponge, lightweight. So firstly, let's do these one at a time. So as you can see, right in front, it's not an AI video. So we drop that. I'm going to put a timer on the screen somewhere, down there, over there somewhere, and you can see just how long each one of these takes to drop. So that's a sponge. We have a fork, and we have a little rubber thing. Now, some of you may have noticed something really interesting there, how every single one of them fell at around the same speed. It was just under a second. So if gravity varies and they all fall at the same rate in a vacuum, well, these have just all fallen at around roughly the same rate under a second. So as we said in the introduction, I'm on Earth. I'm not in a vacuum. I'm not in a Henry Hoover or anything. So explain that one. There's other things that spread. So someone like Isaac Newton said gravity explains the motions of the planets, but it cannot explain who sets the planets in motion. Well, you've already answered your own question, mate. I mean, they're obviously not in motion, are they? If no one can set the planets in motion, so they're not in motion. So why say they're in motion? I mean, I don't really understand that. I think, yeah, that's a bit dumb, really. Albert Einstein, time and space and gravitation have no separate existence from matter. I mean, who even knows what that means? It's just a random bunch of words. Yeah, gravity, no existence from matter. Like it's just word jumble, isn't it? Stop it. And then Carlo Rovelli. I mean, I don't know who that is, but he says if you can't explain gravity quantum mechanically, something fundamental is missing. Yeah, I'll tell you what is fundamentally missing, mate. Gravity. You can't explain it, gravity quantum mechanically, so therefore gravity doesn't exist. Science claims to know all this sort of stuff, but it can't explain gravity quantum mechanically. Yeah, so something fundamental is missing. So, Carlo Rovelli answered his own question without realizing it there. And they also say gravity is the weakest force. It shapes the universe. That was, Dr. Brian Cox. And, He seems like a really great guy. Actually, he seems pretty chill. But gravity is the weakest force. It shapes the universe. So what? Like the universe that is, you know, a, like a few billion, like some light years, size, and then all of a sudden we have this gravity, which is a weak force. Yeah, it's a weak force. Yeah, it can keep like a car on Earth. What? It's so gravity's what? So gravity is shaping the universe, but it's also the weakest force. Yet it can keep 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 a car on Earth like like a blue whale in the sea. And that's the other thing. Like they talk about the moon and how the moon, like you know, affects our oceans and tides and like wow. So you're telling me it can push an entire ocean of water, yet my cup of tea can be like, "Yo, what's up, fam?" It's just chilling on my desk. Like if what tides are coming in and my cup of tea is just chilling. Like wow, do you see all the inconsistencies here? This is madness. It's just like layered and layered on top of each other. Gravity, 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 and all of a sudden it's like, oh yeah, gravity. But um, you know, I want to touch on some other sort of studies that are not widely known about actually, which would give some real sort of have evidence. So in 2021, there was a downward consistency assessment, which was done by the Midland Centre for Alternative Physics, that claimed gravitational variance of up to 11%, 11% in carpeted rooms. How? So gravity is super weak, shapes the universe, but can have a variance of up to 11% in carpeted rooms. That's why they don't want these studies to come out, because it just proves, if there's only 11% variance in carpeted rooms, then obviously gravity can't be real, right? The Household Mass Acceleration Audit, which was done by the British Institute of Terrestrial Dynamics, it found heavier objects fell 0.3 slower in humid conditions. That just proves again that's it's about time we started adding layers upon layers upon layers of real studies to prove to prove what I'm going to tell you next. So hold on for that. I'll break it all down in a minute. And the last one that I read, the preliminary centrifugal behavior correlation paper, which is done by the International Flat Kinematics Society, claims centrifugal force explains 78% of amateur downward acceleration events. Now, the reason that study has been hidden is because we're now going to go on to our next point. Centrifugal force. Centrifugal force is what is keeping us on this planet. If you think about it, you've got the Earth flat, and we're not going round and round like this, because then it wouldn't make sense why I'm sat here. But we have a flat Earth and it's flipping. You ever been on that ground fairground ride where you sit in that like big circle and it spins around really really fast and you're not in a seatbelt, and you're pushed into, like, your back's pushed into. That's what's happening. We're flipping at like 9.8 meters a second squared, which would explain why all objects and gravity accelerates objects at 9.8 meters squared near the Earth's surface. So yeah, we're flipping. We are flipping. Look at some real centrifugal force facts, and this will sort of explain to you why we're living on a flipping Earth. So if the Earth spun faster, centrifugal force could overcome gravity. At roughly 17 times the current rotation speed, people at the equator would be weightless, right? And then there's your threshold. They've measured the exact speed Earth would need to fling us off. I mean, it's suspicious that it's so precise, right? Look at satellites. And actually, satellites, I think, is the reason they tell us gravity is real. Without gravity, satellites couldn't exist. Um, and if satellites don't exist, then well, that's billions of pounds lost revenue for GPS and stuff. Um, and even NASA admits satellites only stay up because they're spinning. So if they're staying up in space because they're spinning, why where that's why can't that explain why we're not just falling in space? We're flipping. Centrifugal forces keeping us in spot. Um, but anyway, look, it's about time people started hearing this information. We need to start spreading awareness of centrifugal force, and yeah, subscribe for some more experiments. We'll be doing some more experiments soon. As you see, this is groundbreaking evidence right here in my living room. No, nothing fancy, no special effects, just hard, real science. So I'll see you in the next video.